If the line is tangent to the circle, then find the value of p. Let us begin. So here we are given a circle. So let's start with the equation of the circle. We have x squared plus y squared minus 2 times a cosine alpha. So let's consider this to be the coefficient of x, minus 2 times b sine alpha. This is going to be the coefficient of y, and the constant term, so that's negative a squared sine squared alpha equals to 0. So this is the equation of the circle that's given to us. So from this equation, we can find out the coordinates of the center as well as the radius of the circle. For this, what we'll do, we'll compare it with the general equation of a circle, which equation is given by x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0. That means we will get the value of 2g will be equals to negative 2a cosine alpha. So here we can factor out 2 from both sides. So if we multiply both sides with negative g, negative 1, we'll get negative g equals to positive a cosine alpha. Then we have 2 times f. This will be equivalent to negative 2b sine alpha. Or simply put, we have negative f equals to b sine alpha. The reason we are taking negative g and negative f, that's because from the general equation of a circle, the center, the coordinate of the center is defined as negative g comma negative f. So that means for our case, our circle is going to have the center with the coordinates a cosine alpha comma b sine alpha. Next, what we'll do, we'll take the constant value c. So that's negative a squared sine squared alpha. Now, we'll need to find out the radius of the circle. The radius of the circle is given by the square root of g squared plus f squared minus c. So let's substitute the value. So we have square root. Now in place of g squared, we're going to get a squared cosine squared alpha. Then in place of f squared, we'll have plus b squared sine squared alpha. And next we have negative c, so that's negative a squared sine squared alpha. So we have negative of negative, so that becomes positive a squared sine squared alpha. Fine. Now what we can do, we can combine this term and this term. This is first and the third term. So here if we take a squared as the common factor, then a squared will get multiplied to cosine squared alpha plus sine squared alpha. And then we have the second term, so that's b squared sine squared alpha. Now, cosine squared alpha plus sine squared alpha, so that is a standard identity with the value equals to 1. So that means our radius is going to be a squared plus b squared times sine squared alpha. So this is going to be the radius of the circle. So now we have the coordinates of the center and as well as the radius of the circle. So we have the circle with center having the coordinates a cosine alpha comma b sine alpha. The radius of the circle is known. I've just found out its value, and we have a tangent, we have a line which is tangent to the circle. So let's call this p. So it's tangent to the circle at point, let's call it point A. Now our goal will be to find out the value of this constant p. So here we are going to use a concept, that means how to find out the distance of any point from a straight line. So let's say we have a point having the coordinates x1 comma y1, and we want to find out the distance of that particular point from the straight line with equation ax plus by plus c equals to 0. Then the distance will be given by the absolute value of a times x1. All we are doing is take the coefficient of x, which is a, and multiply with the x coordinate of the point, so ax1. Similarly, we'll take the coefficient of y and multiply it to the y coordinate of the center, so that's by1, and add it to the constant term of the line. This will be divided by the square root of a squared plus b squared, where a and b are the coefficients of x and y. This is the concept that we will use here. So in our case, we have the distance of the point C, which is the center of the circle, from the straight line, that is the tangent, will be simply CA. CA is going to be, we'll take the absolute value and we'll have to take a ratio. So we'll start with the x coordinate of the center, so that's a cosine alpha. This will get multiplied to the coefficient of x, which is cosine alpha, so that means we get a times cosine squared alpha. Next we will take b sine alpha, which is the y coordinate of the center, and this will get multiplied with the coefficient of y, so that will give us sine squared alpha. Next we have the constant term, so that's negative b. This will be divided by the square root of, so we now have the coefficient of x, that's cosine squared alpha, added to the coefficient of y, so that's sine alpha, and we need to square that value as well. CA is nothing but the radius of the circle in our case. So we have r equals to the absolute value of a times cosine squared alpha plus b times sine squared alpha minus p. Then in the denominator, cosine squared alpha plus sine squared alpha, that's 1. So that means we are going to get two equations. One of the equation will be a cosine squared alpha plus b sine squared alpha minus p, so this will be equals to positive r. And in the other case, we get a cosine squared alpha plus b sine squared alpha minus p, this will be equals to negative r. Since we need to find out the value of p, so let's isolate p to get a cosine squared alpha plus b sine squared alpha minus r. And in the other case, we have p equals to a cosine squared alpha plus b sine squared alpha plus r. And what's r? We have already defined the value of r, so let's substitute. We have a cosine squared alpha plus b sine squared alpha minus r will be the square root of a squared plus b squared sine squared alpha. And the other value p will be a cosine squared alpha plus b sine squared alpha plus r. So r will be replaced with square root of a squared plus b squared sine squared alpha. Fine. So we have successfully obtained the value of